Okay, we're back. So we have the same questions, but a new set of data here. So our new data says, production given the amount invested in capital. So we have, capitals our input in millions of dollars, and then our production is billions of units. So what I did is I went ahead and plugged that into my calculator online here. And as you can see, we have our input and output and our graph. So it looks like, we're going here, that's concave down, but then we move up and we're doing concave up. So we have that inflection point. So that could be logistic, or we could have a cubic, but guess what? It just looks like it's continuing up and continuing down. And so because it has the unbounded endpoints, cubic seems to be the only way to go here. Okay, and so for part A, all I can say is it looks like a cubic, and so it's just going to keep increasing in that. So what I'm going to do is I'm going to just go ahead and do my cubic calculation and say that's probably as good as we're going to get. So we'll go down here, we'll do vars again, 1 1, enter enter. So I'm saying that my equation now is going to be 0.002x cubed minus 0.149x squared, and then plus 4.243x, and then minus 1.550, and that was going to what we're going to have. So let me go back over here and let's start writing stuff down. All right, so for A, describe the behavior suggested by the scatter plot and list types of models. Well, it's decreasing going left, increasing going right, and so it looks like our cubic model is going to be the only one that really works. We have it was concave down and then concave up. So, what we have concave down, then up with inflection point. Okay, and so that really seems to be the key thing. So the end behavior as input increases, well, it's going to increase without bound. Okay, so a lot of this I'm just abbreviating. We kind of talked about it as we looked at the graph. All right, and so it that's what it says. So the more money we put in, the more production we're going to do. Now, does that really make sense? There's going to be some point where it doesn't continue following that. There's only so much capital you can put into something and continue production with that much. So it's going to be a case where I think it won't continue that way forever. But with the way the model is looking, that's what we're going to go with here. Now, what about write the model? So that one, we have P maybe of C, okay? That might be a better way to do it. And we had 0.002x cubed, and then we had a minus 0.149. I'm using C's, and let's put C's. I change here what I was using. C cubed and C squared, and then we had the plus 4.23C, and then we had a minus 1.550, and that's going to be billion units given the production level, gives the production level when C $1 million is put into capital. Okay. And our C is going to be less than or equal to 48, but greater than or equal to our 6. All right. So what are we going to say is the model of best exhibits the end behavior? Well, the only one that really works is same as part C, because with the going all the way up for end behavior unlimited, then we have to use a cubic model in this case. We can't use anything else. But again, will we continue without bound putting capital in? No, there's going to be a certain point where we're going to not put any more capital in, and we're going to reach the limit of our production. So, it's going to have a limit somewhere, but we don't have that with the data given. It's still continuing up. So that's where we're going to stay and go with. All right, so we'll stop, and then I'll come back after I type this in. Okay, we're back. So this time we're looking at the retail price for souvenir footballs at Central University. And so we have years, and then we have the price in dollars for those footballs. Now, because of years, we're going to have to align our data. So that will be 0, then 10, 20, 30, 40, 50, 60. And so what are we thinking about here? We describe the possible end behavior as input increases. Well, as the years go by, it keeps going up. And so what does the price do? Well, it keeps going up too. So I think as time goes by, it's going to continue to go up. So I think that's going to be a key. And so now let's go look what the data actually looks like on a scatter plot. So again, I've typed in the data, 0 through 60, and our data going up in price. And so it looks like it's just going up and up and up. And again, I don't think it's going to stop going up. I think it's just going to continue going up. Now, what kind of data would this fit? Well, it comes down here. It could come down and go back up and be quadratic. Or the way this part of it could be exponential. It could just continue up and just skyrocket going higher and higher as years go by. And so I'm thinking one of those two is going to be our choice. And so what I'm going to do is I'm going to do both calculations because I'm not sure which one's going to fit better. And we'll just go ahead and do the calculations here while we're at it, and then we'll go and we'll look. So let's start with a quadratic, and let's put the quadratic in vars 1. Okay, so our data is 0.0005x squared minus 0.03 6x, and then plus 1.952. Okay, now let's also do our exponential. So we'll go here to calc and do exponential. And so exponential was number 0. And so we go down and we're going to put that in vars 2. And so here we have A, so it's going to be 1.582 times 1.041 to the x. Okay, so now let's see which graph looks better. Well, they both look pretty good. Now it looks like the second one is closer to all the points. The first one is kind of low here, a little high here, higher here, then low, 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 and then high. So overall, I'm thinking the second one looks better. What was the second one again? The second one was the, oops, exponential. So I'm going to go with the exponential. Okay. And does that make sense? Yeah, and they both would make sense because our end behavior on this side over here is going to continue going up. So both of them would work. But I think what's going to happen is it's going to go up more like this, and it's not going to continue as flat as this one seems to be going. And so with this one, let's say for A, describe the behavior suggested by a scatter plot of the data and list the types of models. Okay, well, I'm going to say, again, the quadratic or the exponential. Those are the two, just based on how we talked about the behavior on our graph. And I'm not writing everything down here because we did a lot of the talking. So, if you're doing this, on an exam, you're gonna have to write it here because we're not gonna be talking on an exam. You're gonna have to write down the stuff. So be sure to write everything down as you go. Now, describe the possible end behavior as input increases. Well, it's going to continue. Or where's my in there? To increase as the years go by. At least the output is, okay? So the output's going to continue to increase as the input goes by or the years go by. And I think both of them actually fit that possibility, and both fit. Okay. Now, sometimes, we had the others that didn't always fit, and only one of them actually made sense. Now, we went ahead and we did both models, and we found that the exponential fit closer. It was closer to more of the points. And so our exponential model then, if I remember right, let's say the price with time, that was equal to, and it was again 1.582 times 1.041 to the t. And that is going to be in dollars. Okay, for the price of the football. And that's going to be since 1950, since T years after 1950. And so T was going to be less than or equal to 60, but greater than or equal to that 0. All right, and so D, the end behavior was the best. The best end behavior also was the one that fit the data the best. So again, I'm going to say that's part C. Okay. Sometimes, you're going to have both the models fit really good. And so, again, you could put both models down. But the model that really fit the best on both cases was the exponential there. Okay. All right. So that's all I have for this section. So hopefully that will help.